Me too. What you're doing?
Studying for a test I have today. Trying to understand how the hell to read this.
Crying face emoji.
1914. 1110. 1111.
Which one?
I'm at number 1. I can't read the stem and leaf plot. I don't know how to fucking read this. Doesn't make any sense. Wait a second. 1914. Oh wait. One, 2, 3, 4, 5, 6, 7, 14. No, doesn't make any sense. It's the first question, bro.
Tis literally Albert Einstein type shit.
I think it's a lot easier than Albert Einstein stuff. I just can't read it. I don't know how to read this. I don't even know what I'm looking at. It's 19, 14, n equals 18. So it has to be 18 trials, so... One, 2, 3, 4, 5, 6. 2, 2, 2, 4, 6, 8, 10, 12, 14, 15. 2, 4, 6, 8, 10, 12, 14, 16. It doesn't make any sense. Doesn't make any sense. How do I interpret this? $13.6. I don't even see that. Where are they getting? No, there's no 1 3. 1.
Gooby this, Gooby that, Gooby Wi-Fi, Gooby RAM, Gooby computer, Gooby RAM surrounding Japan, Goobies
You're
everywhere.
interested in which Netflix leaves going on here. And then I have 72, 72, so I got to write both twos, 3, 5, 7.
Oh, okay, hold on. So one, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18.
Orange juice, please, no orange juice now.
That's just fucking bullshit, bro.
9. If I had 40s, 50.
Welcome. Tell us what we are. Place the tens digit.
No, I don't even have that. It doesn't give me that. It gives me leaf unit. Don't know what that means.
Yeah.
Did you do your fucking chores, you piece of Hidjasursky? When I get home, IT better be clean. Oh wow, you did do them well. Too bad I don't care.
Of and then 12 and 7/10. So those are the 12-second race times. 12 and 3/10 and 12 and 7/10. So 12.3 seconds and 12.7 seconds. Let's move on to number 3 and do another example. So we have a stem of 16 and a leaf of 7. Looking at the stem and leaf.
Wait a second.
feet 11, which innocent outliers. And then I have one that we don't have when we draw it by hand. And that's this column of information here, this first column. So I'll come back to that in a moment. Let me show the columns that we do know. So the columns that we do know is the middle column. That's actually
I don't think you can solve. GR, spell.
actually our stem. So be very careful when you're using Minitab output. That first column is no longer going to be the stem. The stem is actually for this one, the middle column. And then the final kind of column is our leaf. And so what's this first column then? Well, the first column is kind of like a cumulative count of data. So if we look at the first row, one,
Like what's a
two,
piece of hit,
one,
bro?
two. And I have 2 pieces of data. And then 1, 2, 3, and I have 3 pieces of data. And then I have 1, 2, 3, 4, 5, and I have 5 pieces of data. So essentially what that first column is doing is it's counting the data.
I don't want to get banned, so I use Temu versions.
Position of data. This is 37 values there. Now the one that I haven't addressed is this one here. What does that mean and why does it have parentheses around it? Well, the one with the parentheses is very useful because that's actually telling me what row the median should be in. So when I go ahead and calculate the median, I know it should be in that row somewhere. And if
Like from his stream chat or it.
row, then I know I went wrong. So it's almost kind of helping me as a check of data. So let's go ahead and now solve the problem. Now we know how we should be reading the Minitab output. Let's use it to help us solve this problem. So the 5-number summary, remember it's the minimum, the Q1, the median, the Q3, and the maximum. So I'm going to start with what I find to be the 2 easiest ones, which would be the minimum and the maximum. To be 114 plus 1 3.4.
I love peanut butter ILVE Pinu M. I don't now spelling I need peanut butter and covered in with my lucking it.
Divide that by 2, which is just going to work. Look at how much data I have. Remember we said our position? I take how much data I have, I add 1, and I divide by 2. And so the position of the median then is going to be 114.
Do you
plus
want the
1,
answers?
Divide it by 2. And so it's going to be in the 57th
Colon my boutique.
5th position. So in other words,
No, I don't want
need
the
to look
answers.
between the 57th and 58th value. And so looking at our data, I know that at the end of here, I have 53 values. And so now I can continue to keep counting. And so that's going to be 54, 55, 56, 57, 58. So there's my 57th and 58th value. And so my median is going to be the middle of those. So my median is actually going to be is just going to work out to be 3.4. So I can do n plus 1 and divide it by 2. So what's n going to be in this case? Well, it's not 114. And the reason why it's not 114 is because that's all of the data. I just need as much data that's below the median. So if we remember, our median is in here. I know at this point is 53 pieces of data, 54, 55, 56, 57 pieces of data is less than the median. So the position is 57 plus 1 and divide that by 2. And so that's 58 divided by 2. which is going to be 29. So my Q1 is in the so that's where my Q1 is, and that's going to be at 3.0. So my Q1 is 3.0. 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. So that's where my Q3 is at. So my Q3 is going to be at 3.7.
What?
17 at this point. And then I'm going to go 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. So that's where my Q3 is at. So my Q3 is going to be at 3.7. Okay, so that's kind of how you would find a 5-number summary using Minitab.
5. B. Wait a second. No. $75 and $90, $45.60. So right skewed means the mean is greater than the median. So A. Median is 19 plus 1 divided by 2. Ten piece of data. Seven. 8, 9, 10. 7.5 or 75. You'll see. IQR. Centuno. 75 is a median. We do 10 divided by 2. It's 5, so they have to be 5 away, which means 3 at the end, 4, 5. So 62 is our 62 is equal to IQ. No. 62 is equal to the lower quartile range, which means you go 5 from here, 2, 3, 4, 5. 83 is going to be our quartile upper range. We do 83 minus 62 is 21. So 21 is going to be our IQR quartile range, which is C. Number 9, standard deviation. What's the standard deviation equation? Oh yeah, this shit. So we have I'm not doing this. I'm doing this on a calculator. $4.49 $51 $59 $61 $62 $64 $68 $70 $73 $75 $78 $78 $80 $81 $83 $84 $88 $90 $93 First var stat calc 12.78. So it's A. If Z is a standard normal random variable, what is the variance of Z? 1. Yeah. B. A particular type of fourth grade achievement test provides overall scores that are normally distributed with a mean of 50 and a standard deviation of 10. Use this information for questions 11-14. So we have mean 50. So we have standard deviation is 10, our mean 50. With this data, we can calculate the z-score. So z is equal to our x, which is going to be 42, minus the mean, which is 50, over the standard deviation, which is 10. So we have 42 we have 42 minus 50 divided by 10, which is going to be negative 0.8. So now what we want to do is go to a z table. And see here that we have negative 0.8 on the dot, which is going to correspond to 0.21186. .21186. So that's going to be C. What is the probability that a randomly selected student earns a score between 33 and 48? So now what we have to do is calculate both. Let's do the z-score of 33 first. So we're going to do 33 minus 50 divided by 10. And then we're going to do z equals 48 minus 50 divided by 10. So here we get 33 minus 50, negative 17 divided by 10, equal to negative 1.7. Then the other one, we get 48 minus 50 is negative 2. Divided by 10, it's going to be negative 0.2. Since we both know the z-scores now, we can calculate the difference in between them. So what we're going to do first is figure out negative 1.7. What's the z-score for that? Seriously? Okay, Wi-Fi, come on. Negative 1.7 is going to correspond to 0.04457. Then our negative 0.2 is going to correspond to
iViewerStream.com.
is going to correspond to 0.42074. So since now we know both of these scores, we can subtract them. We'll get our answer. The bigger against the smaller. So we're going to do 0.42074 minus 0.04457, which is 0.37617. So that's going to be equal to A, approximately. One state wants to allow all students with a score in the top 3 percentile range into a special advanced program. What will be the minimum score required? So in this case, we have, they say that we have to get the top 3%. So we're going to go backwards. We don't have our z-score. We had the percentage. So what we want to do is find where's the 3% here. So we want to look at that. So here we see we're going to, 9%, 7%. Here we get close to 3%, really close to 3%. This is golden. We're really close. This is as close as we're gonna get here. Where'd it go? You have this is probably close. We're gonna. This is probably the closest we're gonna get. At least I think 0.3. So here we have negative, we have z-score of 1, negative 1.88. So now that since we have the z-score, we can work backwards into getting the x. So we know negative 1.88 is equal to x minus 50 divided by 10. Multiply that, negative 18.8 equals x minus 50. Then negative 18.8 plus 50 is 31.2. So our answer is B for number 13. Next question, number 14. Suppose that after the first exam you compute the z-score that corresponds to your exam score on exam 1. Your z-score, so we know our z-score is negative 1.34. Which of the following can you say about your score on exam 1? So we have a z-score of negative 1.34. If we look at the table here, we're going to see that negative 1.34 approximately here means that we're in the 0.09 0.12 range, which is approximately 9% of the population. Bro, it keeps doing that. I'm gonna close it. We know the mean is 50. And the mean has a z-score of 0 because that's where it starts. So what we know is that if our z-score is negative 1.34, then we can get the percentage range. We don't know how good we did. However, what we do know is we can set up an equation to solve that. Negative 1.34, negative 13.4 plus 50 is 36.6. That's your z-score. So considering the mean is 50, we scored below the mean by a lot, which is why we're in the lower percentile range. So it's going to be C. (15) Suppose you're a marine biologist studying a particular species of whales. The average length of this whale species is 60. So our mean is going to be 60. And the standard deviation is going to be 12. The average length of whales is normally distributed. Okay, so we're using a normal distribution graph. You find one member of this particular species of whales and measure it to find its length is 48 feet. So this one is 48, so it means x is going to be equal to 48. What is the z-score? Well, that's not too difficult to calculate. We know z-score is equal to our x, which is 48, minus our mean, which is 60, over our standard deviation, which is 12. So here we have 48 minus 60 divided by 12, negative 1. So our z-score is going to be c here. What is the probability you find a whale smaller than the one referred to in the previous question? So the probability is z-score equals to negative 1, which we can look at that in the table. Negative 1 is going to be 0.15866 chance. So it's going to be B. Number 17. You find old research on the species of whales that only reports the z-scores of lengths and not the actual length of whales. One particular whale stands out to you because it has a z-score of 5.2. So if we have a z-score of 5.2, that means we're trying to figure out the x here. So x minus 48, which is the mean. No, it's not. The mean is 60. So we're doing 5.2 equals x minus 60 over the standard deviation, which is 12. So we can multiply 5.2 times 12, which is 62.4, which is equal to x minus 60. So we subtract 60 and we get a score. So in this case, we're going to have a score Huh. 5.2 minus. We got 122. So that means that the whale is much larger than the mean. So this is going to be A. Number 18. Which of the following is true? The IQR is always bigger than the range for a given data set. That's false. The IQR is always going to be smaller than the range. That's true. The IQR is equal to the range, so it's going to be B. Number 19. Which of the following is not true about normal curves? So in normal curves, they have a mean of 0. Oh, which is not true. They have a mean of 0. Well, that is true. They're all symmetric. That is also true. Hold on. Symmetrical, bell-shaped. Area under the curve equals to 1. Is that true? Yeah, total area under the curve equals 1. So they're all symmetric, that's true. Okay, so they don't have a mean of 0. They have a mean of... Well, the mean is not always going to be 0. That's the point. That's... It doesn't always have a mean of 0. Yeah, the mean could be any real number. So that's gonna be... Why the fuck does it keep scrolling on, bro? Stop doing that. So that's gonna be A. 20. What is the biggest advantage of the standard deviation of the variance? What is the difference? Standard deviation is always smaller than the variance. Well, that has nothing to do with advantages. The standard deviation is calculated with the median instead of the mean. The standard deviation, that's nothing to do with advantages. The standard deviation is better for describing skewed distributions. I think that's true. And then D just doesn't make any sense, so I'm going to say C. Skewed distributions. What is going on? What the freaking Wi-Fi, bro? What was that? $21. Suppose you operate a diamond mine in South Africa. The daily production of diamonds is approximately normally distributed with a mean of... So our mean is 75,000 or 7,500 tons per day, diamond per day. Standard deviation 1,500. What is the probability that the mine produces more than 920? Okay, so now what we want to do, set up the equation. We've got to find the z-score. Z is going to be equal to 9,200, which is our x, minus the mean, which is 7,500, over our standard deviation of 1,500. So when we plug this in, we get a z-score of approximately 1.13 leading. So now with that z-score, we can find out the area to the left of the curve at that point. So what we want to do is go here, 1.13 course, the internet just wants to fucking give up because there's no point in living and it doesn't care about my well-being. So we have 1.13, which is going to be 1.13 leading. So we have a z-score of approx, or not z-score, we have a percentile range of 0.87076. So now with that score, what we want to do is subtract that from 1 to find out what's on the right side of the graph distribution bar. So we're going to do 1 minus 0.87076, which is going to be 0.29, so it's 12%. So it's going to be A. You know, I'll just fucking connect to my phone because apparently between 4,500, 5,400, and 8,200. So what we want to do so 0.59. So I see.
She said me what she said.
0.815 D. An orthopedic surgeon treats many women. An orthopedic surgeon treats many women for back pain. She suspects that one common carried item, the woman's purse, might contribute to this, especially if the purse was heavy. She sampled the purses of 48 women with back pain who were clients at the clinic and got these statistics. What can we say about the shape of the distribution by looking at the output? So, we have 48 trials. We have a minimum of 1,500, a maximum of 16K. Our quartile ranges are listed. Our mean and our median are very similar, although our median is slightly larger. What does that mean? Well, if our mean is slightly larger, then it's right skewed. And I'm going to assume that's going to be the case. And that's how we know that, because if the mean and the median were the same, it would be symmetric. So it's going to be skewed to the right. So we know that this is going to be B. A random sample of 40 middle-class parents are asked how much money they spent on the most recent birthday gift, not including parties or celebrations, for one of their children. Their answers in dollars were as follows. So they list all the values. We have 40 trials. How much money do most middle-class American parents spend on birthday gifts for their children? So we're going to calculate an about. What is an about? An about is an average. What is an average? An average is a mean. So we're going to calculate the mean here. So, like the questions leading up to, we want to calculate the mean, which is A. So 25 is A. Which statement about the median is true? So in order to figure out the median, we need to know the n value. The n value is 40. We're going to do n plus 1, which is 40 plus 1 divided by 2. What does that give us? Well, 40 plus 1 is 41 divided by 2 is 20.5. So what we want to do now is look at the 20.5th value on here. So, hold on.
Oliver Thedham is now live streaming just chatting in cloud.
by 2, 57 and 58th value. And so looking at our data, I know that the end of here, 3.4, count up here and help me not have to count so much. So I need the 29th piece of data, 9. So that's where my Q3 is at. So my Q3 is going to be at 3.7. Okay, so that's kind of how you would find a 5-number summary using Minitab. And so in our example, we had a leaf unit of 0.1. Well, what happens if you have other leaf units? So the then is going to be 114 plus 1 divided by 2. And so it's going to be in the 57.5th position. So in other words,
Oliver Thedham is now live streaming, just chatting him tired.
58th value. And so looking at our data, I know that the end of here, I have 53 values. And so now I can continue to keep counting.
Well, that's not our median. Our median is going to be prox 50. Oh, wait a second. Twelve, 13, 14, 15, 16, 17, 18, 19, 20. Here our mean has to be left skewed, which means our mean is going to be smaller. So B is false.
Counting, and so that's going to be 54, 55, 56, 57, 58. So there's my 57th and 58th value, and so my median is going to be the middle of those. So
we have 12, 13, 14, 15, 16, 17, 18, 19, 20. So 36 and 38. $37. None of these are true, though. I'm just going to go A. A popular news magazine wants to write an article on how much Americans know about geography. They devise a test that lists 100 cities in the U.S., all of them. They devise a test that lists 100 cities in the U.S., all of them mentioned in the news magazine in the last year. Each respondent must guess the state in which the city can be found. Some examples were Los Angeles, Tucson, Biloxi. Each correct answer earns 1 point, for a maximum of 100 points. The random sample of 5,000 people had a distribution of scores that was normally distributed with a mean. So, mean, 62, standard deviation, it's 12. The random sample of 5,000 people. So, S equals 5K. The central 95% of people. Okay, so this is where we're going to use Simpson's paradox. Dude, what is that thing called? The empirical rule. So, 95 observations within 2 standard deviations of mean. Well, we know it's just standard deviations. So, two standard deviations. So we're going to have 95% of people. So if the mean is 62, what we want to do is get 12 under and 12 over. 12 under is going to be 50. 12 over is going to be 74. So our answer is going to be C. 27 is C. Bada boom, bada bam, bada boom, bam, bam.
Picking up the pace, I'm dragging out the race. Final win first place, I gotta finish in last. No matter the skill, it don't matter the will. Anyone can pass the real, that's just as fast. Oh, matters that you true, to leave that's what you do. For the fame, don't pursue. I got logic, stick like glue. Pocket rocky, I just threw. Grown in size, burst like glue. Turn it up, turn it up, turn it up. And I got the race, fuck your face. Make this place even if I never get brains. Look, I've been through good and bad. Don't got those designer bags, but a ching 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 when I walk your ass. It's a pain they have me, spits and facts. Maybe those it may be an afterlife. Maybe those will stop you like knife. Maybe those will spread out like rice. Let the state of flow put you in the zone. Posters are all waiting now. Picking up the pace, I'm dragging out the race. Trying to win first place, I gotta finish eating last. No matter the skill, it don't matter the will. Anyone can pass the real test, just as fast. Picking up the pace, I'm dragging out the race. Trying to win first place, I gotta finish eating last. No matter the skill, it don't matter the will. Anyone can pass the real test, just as fast. Exposing, don't know what to do. Exposing, I ain't got a clue. They say pursue the true and you put my heart, say no new. Heart giving me a heart attack, thought rapping was not the move. So I'ma keep it stacked. You guess I'm coming back in black, cause I'm absorbing all the heat from traps. I'ma eat this track, black snack. Hanging up lyrics from the rack, so I reuse every word I pack. I never slack, try not to lack. Can't think I got my rhymes stack. I'ma be right back with a pin attack. Hang you up like a depressed stack. Maybe then I'll get my diamond plaque. 2 step, I need my bones to crack. Don't intercept, I want no pack.
Can't see on the bass.
Alright, let's do this one last time.
Picking up the pace, I'm dragging at the race. Trying to win first place, I gotta finish it last. No matter the skill, no matter who will. Anyone can pass the real time shots as fast. Picking up the pace, I'm dragging at the race. Trying to win first place, I gotta finish it last. No matter the skill, no matter who will.
Top 5%. Negative 1.64. B. Don't intersect that one.
Yeah, sir. I'm in these streets, playing fucking beats that don't do nothing. Bouncing, jogging that ball, you mind me falling back in fucking prom. I see beats like I'm back in time, yeah, back to back suburban, double line, yeah, back to back. I'm undogging these streets, repping the rap game since 2018. Jumping in trap, I'm a C for work, taking chart, work, figure, I'm a fucking nerd.
Shit. Ain't gotta tell you twice, I'm a motherfucking boss on the streets. Looking at me in my face to see if I gonna be tweaking. I don't feel none of this point, I feel like I'm losing the battle.
0.79.
Get a fucking saddle, bitch, cause you know you gon' get rattled. Hop on a horse,
B.
ride in the Porsche, I'll let indoors. Mix my flow, pull up on the door. Them
People want more.
haters gon' hate, nothing I can do for all that I speak. When you don't pick flaws in the song, you just work to looking at me. But they don't know what I made it change, it's all that I know. Realize, I keep on the low. Knew that shot you out, you sliming hot, big boy, you got some marks sliming, you been pop like a guitar, I'm gon' get down like I get shot, I speak the phone, don't turn it off, you miss the word and you'll get mouth, still trying to say I won't stop now, I done been called a fucking clown, babe, ain't no tricks when I'm around, but I will promise you then, see this town, this is my hobby, will go down, fucking around, playing the ground, finish it down. Missing the signs, no one to help, you lost and found. Bouncing from place to place, like it's a race. I'm like a turtle, you like a rabbit, missing a hurdle. I went first place, then you debate. Who did it first, boy, you too late. When I'm on my grind, I wanna shine. When I'm in the dark, I won't see the spot. Give me the time and I rhyme in the line and building a clock. Connecting the dots, set into the jail, boy. Shit. Bouncing on my seat, bouncing on my beat. I put my fucking mother seat. I've been the bucket on my beat. I've been the bucket on my beat. I've been bouncing on the streets. How we know when you bounce too far? How we know when you jump in the wrong hole? Wrong hole, wrong hole. Fucking around, playing the crown, getting shit down.
B.
No one to help, you lost and found. Bouncing from place to place to place, like it's a race. Hop on the horse, ride in the Porsche, all the indoors. Mixing my flow, pull out my door, then people want more. Them haters gon' hate, nothing I can do for all that I speak. When you don't pick flaws in songs, just what you're picking up me.
Yeah, I should probably go now if I'm gonna go for